the recording. This is Algebra 2 on Tuesday, it's Wednesday, January 14th, 2015. We're on page 239, looking at section 5.4, factoring polynomials. Remember that polynomials are nothing more than a long string of monomials, however you want to say it, and we can always simplify them. Yesterday we learned how to divide them, and we used our power rules to make them smaller and things. Today we're going to learn many ways to factor them, which is just another fancy word of saying simplify. How you factor them depends on what type of polynomial you have. Some have only squared terms, some have only cubic terms, and so on. And some have what we know as common factors. For instance, common factor between 4 and 8 is 4. The common factor between 3x squared and x is x. So we use this stuff to simplify all these crazy polynomials that they're going to throw at us this section. How does factoring apply to geometry? Well, suppose that an expression exists of 4x squared plus 10x minus 6, and that represents the area of a rectangle. Factoring can be used to find possible dimensions of the rectangle. And they show a pretty little picture. If you factor, it sort of tells you the length of each side. And there's a question mark on each side of the rectangle that says how many units? Okay. In the middle of the page, it gives us a paragraph that says factor polynomials. Who wants to read? Typey type people. Anyone? Huh? It's you two.
Oh, is it?
That's it. I have to record because they're both gone today. I forgot Stormy was on a short schedule. Okay. Were you even listening? Factor polynomials, paragraph below the little box.
All numbers are factored using prime numbers. For example, 100 equals 2 times 2 times 5 times 5. Many polynomials can also be factored. Their factors, however, are other polynomials.
Yep.
Polynomials that cannot be factored are called prime.
Just like in numbers. Our prime numbers are 2, 3, 5, 7, 11, 13, so on. And we have prime factor polynomials such as x minus 2. There is no way to simplify x minus 2 in any way that we understand. So below this fancy paragraph is a table that I encourage you all to mark in your books. Or, as Josiah did, memorize it. Or copy it. Because you will need to know, because it gives you the number of terms. So how long is your polynomial? The name of the factoring technique, and what the general case looks like. For instance, like what it would look like without numbers, using symbols in mathematics. Greatest common factor, GCF, we all know what that means. For instance, in the first row of this table, we have a cubed b squared, 2a squared b, and minus 4ab squared. What does every term have in it? Has an a. Each term has an a in it somewhere. Two of them have an a squared, a and b actually. Two of them have an a squared and a b squared, but all three of them have at least one a and one b. So you could totally factor out, just like you would in, like if you were finding fractions and things, you would factor out an ab of each term. So taking an a out of a and a b out of a cubed b squared leaves you with two a's and one b. Taking an a and a b out of the next term, 2a squared b, leaves you with 2, because that's not a like term, a. just leaves you with 2a. And lastly, taking an ab out of minus 4ab squared leaves you with minus 4b. And it shows it for you after the equal sign in the first row of your table. So again, you would write the factor outside, open your parens, and write what's left, and then close your parens. I'm not going to go through each and every one of these types of factoring, but you'll hear me use some key words. For instance, difference of two perfect squares, sum of cubes, difference of cubes, perfect square trinomials, so on. So this section is going to be comprised of which factoring method do we need to use, and we need to go to the table and figure out how to do it. And this is a good skill to have, because in college, they're not going to go through every single step with you or for you. You'll have to read the book and go through the examples and see if you can figure it out. So I would consider this a reference table, a very important reference table, because I'll give you a few of these on an exam, and you'll have to use the correct factoring technique to figure out how to simplify it. So let's see, how many are there? 1, 2, 3, 4, 5, 6, 7. 7 of them. So just FYI. Josiah thinks he has them memorized, so we can test his knowledge throughout these examples. He says no. Oh, now he re-says it. You're supposed to have it memorized. Okay. Here we go. The first example above the, continuing down the page, it says, whenever you factor a polynomial, always look for a common factor first. That's really good advice. Always see if you could do it the GCF way first, because then it makes your life a heck of a lot easier. And then determine whether the resulting polynomial factor can be factored again using one of the methods in the table or above. All right. Hint, hint. Right below that is example 1, GCF. What method do you think we're going to use? GCF, i.e. greatest common factor. So find example 1, and here we go. Factor 6x squared y squared minus 2xy squared plus 6x squared y.
X cubed.
Huh?
6x cubed.
Oh, it's a cubed. Got it. 6x cubed y is the final term. All right. Who can tell me what the GCF of this thing is? Without looking down. What do each of these three terms, what can we take out of each of these three terms? Yep. What do you think, Josiah? What can we take out of each of these three terms? A what?
Hold on.
No.
I have to read it.
Oh, hold on.
I was all taking notes.
Oh, jeez. Well, you know, I had a college professor once who wouldn't allow us to take notes because she felt like we weren't listening. And that's, I'm seeing the wisdom in her. So, FYI, you're going to have some crazy college professors. Right. Don't look down. Tell me if you could, what the GCF of those three terms is. What can come out of each?
A lot.
Yeah. Start with the numbers. What number can come out of each?
2.
2. How about x's and y's?
X.
X, sure. They each have at least an x, okay?
Y.
And a y, right, because there's no y squared in each of them.
Yeah.
Okay, so yeah, you would factor out a 2xy. So on your paper, you would just write 2x, because that's 2xy, pardon me, as your common factor. And open up your parentheses and divide all that out and see what's left. So 2xy open parens, and then let's factor it out. What's 2xy out of 6x squared y squared? 3xy, right? 6 becomes a 3, x squared becomes an x, so y squared becomes a y. So then, then you'd write a minus sign, and now take a 2xy out of negative 2x squared, or xy squared. That becomes negative 1 y, because x out of x is nothing. Well, 1. Y squared out of y is just, or y out of y squared is y. And lastly, we take out a 2xy out of 6x cubed y. The 6 becomes a 3. The x cubed becomes an x squared because it was only x to the first, and y goes away. So we're left with those three terms inside parentheses. 2xy open, 3xy minus y plus 3x squared. That's what happens. You just take each piece out of each term, just like we do in regular numbers, except now you just have some x's and y's to balance. How does that feel? Not too scary, I hope. I guess it is scary. A GCF is also used in grouping. Grouping and factored of polynomial terms. Grouping. So, grouping, it's in your table. It's the very bottom of your table at the beginning of the section. It's nothing more than separating your terms into as common as you can. So separating them into x terms and separating them into y terms so that their coefficients are the same. And we're going to practice it. Because parentheses open a plus b and parentheses a plus b, they're like terms. We're going to talk about this. Grouping took me a very long time to understand when I was your age, because it's wonky. Let's look at example 2. Let's see if we can figure it out. It's at the very top of 240, below the page break in Braille. And it says, factor a cubed plus 4a squared plus 3a minus 12. Pardon me. We want to be able to turn this thing into terms we recognize and can further simplify. So you would just rewrite it again. A cubed minus 4a squared plus 2a minus 12. Now we can separate in them. So you want to separate these in such a way where each of them has a common factor you can take out. So for instance, in their first set of parentheses, they have a cubed minus 4a squared. Well, in that particular set of parentheses, we can take out an a squared from each. Yahoo! That's good. And in the second set of parentheses is a plus 3a minus 12. We can take out a regular 3. So they made it easy for us, and all they did was separate out the first two terms from the second two terms in this I guess it's a quadrinomial, I don't know, and made it so we could factor this out. So if we look at the first set of parentheses again, and we take out the a squared, we would write a squared, open paren, a minus 4, close, because we just factored it out. A squared from a cubed is just a squared from minus 4a squared is just minus 4. And then you close it out. Then you move on to the second set of parentheses, which is 3a minus 12. We could take out a 3 from both, because 3 goes into 3 once, and 3 goes into negative 12 4 times. So then you would write plus 3, open, a minus 4. So notice the whole reason we do this is so we could get the same thing in parentheses. Because what happens when you have the same thing? They're like terms. So what if it's an open a minus 4? They're still like terms. Does that make sense? It's not an x. It would be just the same as saying a squared x plus b 3, b x. the a minus 4 makes it a like term. So therefore, we can add their coefficients. The coefficient of the first a minus 4 is a squared, and the coefficient of the second a minus 4 is 3. So that's why the very bottom line of the example, they have a minus 4 times a squared plus 3, because they just combined the coefficients. Because you can do that when they're like terms. It doesn't matter if they look weird. If they're the exact same, they are considered like terms. Also note, they're in parentheses. If it just said a minus 4 without parentheses, we wouldn't be able to do this. It's a quantity. Do you have any questions about this part? Grouping might take a little extra time because you'll have to figure out what grouping of numbers will allow you to make this work. You can also use algebra tiles, which we're going to skip. We're going to skip the section where it says algebra activity. I don't actually have any algebra tiles that I'm aware of.
Good.
Okay. See if you can find below the box where it says the FOIL method. Who remembers how to FOIL? Oh, good. You have your two sets of parentheses, first, outer, inner, last, and those just refer to the orientation of the symbols. So what's on the first in parentheses, what's on the outer edges of parentheses, what's in the middle, and what's last. So they just give us a reminder of what foiling is. And says at the very bottom of the page, it says, notice that the product of the coefficient of x squared and the constant term is, A, B, C, D. That's kind of interesting. The product of the two terms in the coefficient of x is also A, B, C, D. That becomes important later.
What does that mean?
Well, when they did all the work with symbols,
What is the product of the coefficient?
because, you know, when you, Miss Chris, when you factor what multiplies to be the constant adds up to be the middle term,
Oh.
that's where this comes from. They'll learn it shortly. Hopefully.
Sorry, I sat on my phone.
What?
I sat on my phone.
Ah, does it work? All right. After the page break / next page, we have example 3, where we have A, B, C, and D to get through. And there are just different factoring types that we can learn how to factor via the table on the previous page. Well, 2 pages ago, actually. Okay. Factor each polynomial. Okay. What about this one? What kind of polynomial is A? Which method would we use?
The trinomial.
Yeah, it's the trinomial. So this is when we get to quadratic functions, this is the one we're going to use the most. So you want to know a trick? We're going to read about the book actually gives it to you. You want to find a number. See where it says right below A. It says to find the coefficient of the x terms, you must find two numbers whose product is 5 times 6. So notice 5 times 6 is the first term in the trinomial times the last term in the trinomial, but also adds up to be negative 13. Can anybody think of a number that multiplies to be 30 and adds up to negative 13? You get really good at this in your brain. So think of factors in 30. Would 1 and 30 work? No. 2 and 15? No. How about negative 10 and negative 3?
negative.
Yeah, because negative 10 plus negative 3 is negative 13. And, of course, negative 10 times negative 3 is positive 30. So, what you do with that information, those are what go inside of your parentheses, that negative 10 and negative 3. So you would rewrite the expression using negative 10x and negative 3x in place of negative 13x. Okay. So that's 5x squared minus 13x plus 6 becomes 5x squared minus 10x minus 3x plus 6. So recall, minus 10x plus, or minus 3x is still negative 13x. So all they did was separate the 10x into, separate the negative 13x into two like terms. So we can group them. That's what they continue to do here. They group them. Like we did in the prior example. They said they put the first two terms, 5x squared minus 10x in one set of parentheses, and a minus 3x and a positive and the positive 6 in the second set of parentheses. So what's the GCF of 5x squared and 10x? The first set of parentheses. What's the GCF of the first set of parentheses? 5x, that's right. And then we just take out 5x. 5x, open paren, 5x squared becomes an x. The 5 comes out and an x comes out. And the minus 10x becomes a 2 because the 5 comes out and the x comes out. So your first set of parentheses is 5x, open, x minus 2, close. Now we can't forget about the second set of parentheses. What is the factor, the GCF of negative 3x plus 6? Yeah, you can do that. You generally do not want a negative, the first thing inside of your parentheses. So if you can take out a negative, that's a good thing. So then it will be minus 3, because it's a negative 3 that you took out, x minus 2 inside. Because all you're doing is taking out a negative 3 from 3x, or negative 3x, it becomes an x. And positive 6 divided by negative 3 is negative 2. So then we have an x minus 2 in both sets of parentheses. So again, we can rewrite these as like terms. This open paren x minus 2 is common to both. So your final answer is open 5x minus 3, close, open x minus 2, close. Because they are like terms. So you just add, or in this case, subtract the terms and keep the x minus 2 the same. Oh, phew. Okay. What about B? I like this one. It looks to me like it's a GCF problem. Part of it, anyway. What's the GCF of B, which is 3xy squared, excuse me, and minus 48x? Oh, xy squared, yeah. So there's, first check the numbers. Well, the GCF between 3 and 48 is 3. And the GCF between xy squared and x is just x. So when you, again, we factor out the 3x in each term of the polynomial. So you'd have 3x, open parens, what's left? A y squared and a minus 16. This looks familiar. We have a y squared minus 16. What kind of thing is a y squared and a 16? Can anybody think about it? This is something you'll have to keep your eyes peeled for, / fingers peeled for. Y squared and 16 are perfect squares. So we have a 3x outside and a y squared minus 16 inside. So we have a square minus a square. Therefore, we use the difference of perfect squares from the table at the beginning of the chapter. Difference of two squares. second one down. And when you do that, this one I have memorized, Mr. Josiah. This one's one you'll see a lot. Hint, hint, wink, wink. Okay. When you do the difference of perfect squares, you can't forget that that 3x is still sitting out there. So you would write the 3x and then use your difference of perfect squares. What's the square root of y squared? Square root of y squared. Y. Square root of 16. 4. So all the difference of perfect squares says is open your two sets of parentheses and write the squares in. One with a plus sign and one with a minus sign. So your answer is 3x, because we factored it out, open, y plus 4, close, open, y minus 4, close. So you're just putting the squares inside your sets of parentheses and putting a plus sign in one of them and a minus sign in another one. You can always check when you fill it out. Y times y is y squared. Outers, minus 4y. Inners, plus 4y. They cancel. And then 4 times negative 4 is negative 16. It works. Because you can't always trust everything, right? Okay. Here we go. C. So it looks to me like it's going to be a cubic. I don't know about you, but 27 is a perfect cube. And so is C cubed, D cubed. But you're going to have to do some rewriting before you can say it's the sum of cubes. Because it's not, the term is C cubed, D cubed. You can't just leave it like that. You have to separate it. Otherwise, it's not a perfect, it's not in the form of the way that the table wants it to be in. So you would rewrite this as open paren, CD, close, to the power of 3, plus, what's the cube root of 27? It's 3, plus 3 cubed. Now you have a perfect set of cubes. This is a lot to remember. We might be practicing this today and tomorrow, so that's okay. CD cubed and a 3 cubed. But then we just follow the formula. And in our table, I'm going to keep flipping back. It is sum of cubes. Third one down. You have to have it in the form of some version term a cubed and some version b cubed. So in this case, our a term is CD because it's what's cubed. And our b term would be 3. So it's very important that you're careful and that you know which term is your a and which term is your b in each factory thing that you do. And you'll use these so much that, yes, you will have some of them memorized. Just saying. Okay, so again, A in this is CD and B is 3. So then we're going to do it. It says in our formula that the first thing we do is open up a set of parentheses and put A plus B inside. So in this case, it would be open paren CD plus 3 close, because they're just A plus B. That's all the first thing is. And there's one more thing we have to do. We have to open up a second set of parentheses and put in what it says. It says A squared minus 3, or excuse me, minus AB plus B squared. So open paren, our A term was CD, so you put it in parentheses to keep it separate. CD squared minus 3 CD plus 3 squared, close bracket. Okay, so all we're doing is plugging and chugging. That's my favorite expression. We're plugging and chugging. If you know what your A and B terms are, you just follow the formula. In all honesty, this is not my favorite type of math because all you're doing is following a recipe, so to speak. So for you folks, it is very important that you learn which recipe you're going to follow and which terms are your A's, B's, and C's. So it will be good practice for you to learn how to follow formulae. So when we plug all this stuff in, CD plus 3 stays the same, but the second set of parentheses we can do some fun stuff with. CD squared becomes C squared D squared by our power of products rule, or product of powers, whatever. Minus 3 times CD is just 3CD, and 3 squared is 9. So your final answer is that 2 string of parentheses. Open CD plus 3, close, open C squared plus D squared minus 3CD plus 9, close. You are done. You have followed the formula and simplified as much as you can. I feel like after all that talking, I need to take a breath. How do you two feel about this stuff? Huh? Yeah. Again, the trick is just to follow the formula you're given as best as you can. Ooh, the D is a trickery. M to the 6th minus N to the 6th. We can separate this out. It's kind of fun. Because if you think about our power of products rules, we can turn M to the 6th and N to the 6th into squareds. So you'll have to get really good at thinking of tricky tricks that you can do with your power rules. For instance, we can change M to the 6th into open M cubed closed squared. Because what's M cubed squared? M to the 6th. We can also do the same thing with N. N to the 6th is the same thing as N cubed squared. Or N cubed times N cubed. Same thing. So that's what this trickery of D did. They rewrote it in such a way where you can have the difference of perfect squares. Because that's my favorite factoring form. Because the difference of perfect squares is nothing more than, open up your parentheses and saying the first square plus the second square, closing, opening, first one minus the second one. So that's why this one is M open parentheses, M cubed plus N cubed, close, M cubed minus N cubed, closed. And notice something else. The first set of parentheses is the sum of cubes, and the second set of parentheses is difference of cubes. That is a lot. It's a lot. So once you'd actually separate it, you would have to do 2 different things again. You would have to use the M cubed and N cubed sum for the first set, and you would use the difference of cubes for the second set. Now again, I don't expect you to memorize all of this, but I would like you to have an idea of which factoring method to use when you're presented with this stuff. So that's why the monster on this example is open M plus N close, open M squared minus MN plus N squared closed, open M minus N close, open M squared plus MN plus N squared close. Because they had to use 2 separate cubic factorization formulas. So again, we had to separate the 6th into perfect squares, and then we had to separate the cubes into sums of cubes. Oh my goodness. Does that hurt anybody's brain? Yeah. Luckily, we don't have to do anything more with that. You could just leave it in this long string of stuff, okay? You can leave it in this long string of M's and N's. I feel like I'm always saying M and M when I say M and N. All right. We're again going to skip the graphing calculator thing. It does factor for you, just so you know. Please turn the page. We have one more to get through. We can cancel. We can simplify quotients in lesson 5.3. Remember the whole division thing? You learn to simplify the quotient of 2 polynomials by using long division or synthetic division. Some equations can be simplified using factoring. So, remember when you used to do multiplying fractions and it would be like 2/3 times 3/5, and you could cross cancel the 3's because one was in the denominator and one was in the numerator? This is similar. This is similar. So quotient of two trinomials. X squared plus 2x minus 3 over x squared plus 7x plus 12. Now here's a good time to check your knowledge of how to factor trinomials. So the thing to remember is what multiplies to be the last term and adds up to be the middle term. Let's look at just x squared plus 2x minus 3. Can anybody think of what multiplies to be negative 3 and adds up to be 2? Positive 2. What are the factors of negative 3? There's only one set. Huh?
Multiplies to be negative 3.
That's right. What multiplies to be your last term, which in this case is a negative 3. What are the only factors of negative 3? 1 and 2. So which one needs to be positive to add up to 2? Like when you add,
Positive.
so it needs to multiply to negative 3 and adds up to be positive 2.
Oh.
So would it be negative 3 and 1 or positive 3 and negative 1? Which one will make that a positive 2?
Negative.
Right, you want the negative 1 and the positive 3. Because negative 1 times 3 is negative 3, but 3 plus negative 1 is 2. This will take some practice, and that's fine. You're going to have a lot of chances to practice this when we get to quadratics. So when you do that, you would rewrite your numerator in those terms, in parentheses that look like foiling. So look at the next line down where they do it, except ignore the x parts for now. You would rewrite x squared plus 2x minus 3 as x plus 3 and x minus 1. Because if you FOIL that out, you will get x squared minus 3x, or excuse me, x squared minus x plus 3x minus 3, and it would work. So when you do this, again, you're just making a set of parentheses you can FOIL. So let's look at x squared plus 7x plus 12. What multiplies to be positive 12 and adds up to be 7? So think of factors of 12. What are some factors of 12?
3 and 4.
Yeah, that would totally work. Yes, good going. 3 and 4. So you would open up your parentheses and say x plus 3 and x plus 4.
You always do like that, the x plus 3 or x plus.
Yes, x plus something or x minus something. Because when it multiplies to be a negative, you will always have one negative number in there. And there's other tricks you can learn about. So if you look at what they did, they have x plus 3 and x minus 1 in the numerator, and x plus 4 and x minus or plus 3 in the numerator in the denominator. So we have 2x plus 3. So just like fractions, we can cancel them. We can cancel both x plus 3's. So in the numerator, we're just left with an x minus 1, and in the denominator, we're left with an x plus 4. That's how we do that. And I encourage you to practice factoring trinomials. You're going to do it a lot. You won't see cubic, sums of cubics very often, and you will see difference of perfect squares fairly often. And you will always check for greatest common factors. So again, you factor the numerator into 2 sets of parentheses, and you also factor the denominator into 2 sets of parentheses, and see if you can cancel. In this case, we could cancel the x plus 3's. You ready? I don't know. Let's just do 4 through 11. Oh, and 12, because I want you to do one simplifying one. 4 through 12. One simplifying one would be great. 4 through 12. Use your table carefully. Be sure you know what you're doing, and copy carefully. Know what your A and B terms are. Stopping recording.